K-maps. Now, K-maps is basically also called Karnaugh Maps. Now, this is something which is going to make our life easier, because whenever we have any expression, so with time we need to summarize that expression using different Boolean algebra rules. And with the K-maps, we will be able to actually have more precise way of dealing with the expression. So let's suppose if we have two variables, let's suppose we have two variables, let's suppose x and y, right? So this means we will have a total of four combinations, because x can take two values 0 and 1, y can take two values 0 and 1. So this means a total of four expressions, means we will have a total of four min terms, starting from m of 0, m of 1, m of 2, and m of 3, right? Are you with me?
Yes.
Right? So m of 0 is actually representing 0, 0, right? M of 1 is representing 0, 1. M of 2 is representing 1, 0. And M of 3 is representing 1, 1, right? Now, if we want to see M of 0, M of 0 is actually taken as x complement, y complement. M of 1 is being taken as x complement, y. Similarly, m of 2 is being taken as x and y complement, and m of 3 is being taken as xy, right? So now if you see, if we go for the K-maps, so, and if we have two variables, so K-maps is always being represented in terms of boxes. So the K-map, if we have got two variables, so this means how many boxes do we need to represent the K-map for two variables? So if you see, we have a total of, for two variables we have total of four minterms. So this means we need to make four boxes. And how we can make four boxes? We can simply straight away say something like this. If we say this is the x side and this is the y side, right? So in the first row, we say x is 0. And in the second row, we say x is 1. Similarly, in the first column, we say y is 0. And in the second column, we say y is 1. Are you with me?
Yes, sir.
Now, if you see in the first very box, where x is 0 and y is 0, we say this is going to be min term m of 0. Now in this complete row, x is 0. So in the second box over here, x is 0, y is 1. So we say this is min term m of 1. Then if we go into the second row and the first column, we have x is 1, y is 0. So this means it is min term m of 2. And then in the next vacant box which is being left, we say it is representing x is 1 and y is 1. So we say this is m of 3. Are you with me?
Yes, sir.
Any question up till now?
No, sir.
Okay. Okay, so with this, what we can say, that we can straight away say that this is x, this is y, and these are representing x complement y complement. This is representing x complement y. This is representing x y complement, and this is representing x y, where x is 0 over here, x is 1 over here, y is 0 over here, and y is 1 over here, right? Now if we say we have a function for x y, and we say this is equal to m of 3, what does this mean? Or if I say this function is equal to summation 3 only, so what does this mean? Anyone?
Yes, sir. I think this means that only on three mean terms M3 there will be only one means on. Other remaining boxes will be zero.
Okay, so you are right. So this means when we say fx function with xy and it is equal to m3, or I say summation with a bracket 3, so this means we have basically the k map for x y, which is 0 1 0 1 over here. So this means I have one only in this box, right? If I say I have a function xy which is equal to x only, so what does this mean? Anyone? If I say the function xy is equal to x only, or if I say this function is equal to m2 plus m3, what does this mean now?
There will be a one on min term M2 and M3.
Okay, so if you see, this means I can add one in the box which is representing min term m2, right? Are you with me?
Yes, sir.
Now I said this is also equal to x as well, right? So what does this mean? This means that if you see that I have basically taken this m2 as well as I am adding m3, right? So m2 is basically equal to the function m2 is equal to x y complement, right? Plus m3 is equal to xy. Are you with me?
Sure, sir.
Now if I take x common from both the terms, I am left with y complement plus y. Now what is y plus y complement equal to?
One.
One.
Right? So this means the function is equal to x only, right? Are you with me?
Yes, sir.
Yes.
And therefore in the start I have written the function xy is equal to x, right? Similarly, if I say the function, if I say function is equal to y, right? And then in the K map, again, if you see, I have x and y. X is equal to 0, x is equal to 1 over here in this whole row, and y is equal to 0 and y is equal to 1 in these columns, right? When the function is equal to y, so this means it is basically representing, whole of this column, right? Are you with me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Or I can say the function is equal to m1 plus m3,
M1 plus M3.
right? So this means there
Yes, sir.
is 1 over here and there is 1 over here, right? And what is m1? M1 is equal to x complement plus y. What is m3?
Y.
X, y, right?
Y.
So what we can do, we can take y common. So we are left with x complement plus x. What is x complement plus x?
1.
So this means this is equal
1.
to y
1.
only, right? Are you with me now?
Yes, sir.
So this
Yes,
means
sir.
this whole column is representing y complement. This whole row is representing x complement. This whole row is representing x only. Are you with me now?
Yes, sir.
So this is representing x only. This is representing x complement. Now this whole is representing y and this whole is representing y complement. Are you with me
Y
now?
complement. Yes, sir.
Any question up till now?
No, sir.
Okay, if I say I have a function, which is equal to x plus y, are you with me now?
Yes, sir.
So if the function is equal to x plus y, how we can represent in the K-map? I have x, y, it is 0, it is 1, it is 0, it is 1, right? So what we have established up till now, that this whole row is representing x. This whole column is representing y. Are you with me?
Yes, sir.
So this means the whole column should be having 1 and this whole row should also have equal to 1. Are you with me?
Yes, sir.
Right? So this means this function
M1 plus M2 plus M3.
m1 plus m2 plus m3 will be equal to basically x plus y, right? Are you with me now?
Yes, sir.
Right? So this means we can actually have more control now on the Boolean expressions. And similarly, if I say the function is equal to 1, right? When I say the function is equal to 1, so this means all the boxes, they are equal to 1, right? And in that specific case, I will put 1 over here as well. Are you with me now?
Yes, sir.
Right? So this is basically the K-map for two variables. And in this, if you see, we can make groups. How we can make groups? We can make groups of the adjacent boxes. The adjacent box is something like this. If we can make a group like this, and similarly, we can make a group of two like this, right? Now, this, if you see, this whole column is representing y, and this whole column is representing y complement. Are you with me?
Yes, sir.
So this means what we say, that the function is equal to y complement plus y, right? And what is y complement plus y equal to,
1.
1.
right? So therefore what we have said, that the function is equal to 1, right? Are you with me now?
Yes, sir.
Yes, sir.
Similarly, I can say that I have made the groups in the vertical direction. I can make the groups in the horizontal direction as well. If alls are 1, this is x, y, 0, 1, 0, 1 over. If I make the groups in the horizontal direction, the adjacent groups, right? The two boxes can be made in a group, one group, and this is another group, right? So this row is representing x complement, this row is representing x, right? So the function is equal to x complement plus x, which is again equal to 1. Are you with me now?
1.
Yes,
Is
sir.
this
Yes.
thing fine?
Yes, sir.
Okay, so now let's move to 3 variables K-map. Now in case of 3 variable K-maps, let's suppose we have the x, y, and z, right? So if we have got 3 variables, so this means we can have a total of how many minterms?
8
6.
minterms.
So this means we have going to have a total of 8 minterms, right? Now
Yes.
when we have going to have an 8 minterms, so this means we will be requiring how many boxes?
8 boxes.
So this means we will be requiring 8 boxes. So 8 boxes can be either drawn in this way. So I say this side is x, this side is yz, and then I put a line in between. So this I can make 8 boxes, right? Now when I can make 8 boxes, so in the start I will say x is equal to 0 for this whole row. So this means this whole row will be representing x complement. And similarly, if I put 1 over here, so this means this whole row will be representing x over here, right? Now I have yz over here. So what I do, I put y as 0 and z as 0 in the first column. Then what I will do, I will put y as 0 and z as 1, right? So we have to have the understanding that only one of the two variables can change the value at one time, right? Because otherwise the K-map will not be holding good for the Boolean algebra. So we need to have the changes in the adjacent column only for one variable, right? And for that very reason, the next column will be labeled as 1 1 over here. Kindly turn off your mics, please. Right? And therefore the adjacent column is going to have a change in only one variable. So therefore we put y is equal to 1 and z is equal to 1. And in the next adjacent column, we change the z only. So this means y is 1 and z is 0 over here, right? So now what we can see, that which specific min terms the box is going to be labeled with. When x is equal to 0, y is equal to 0, z is equal to 0. So this means this is representing m of 0 over here, right? So because this is 0 0 0, Now the next adjacent box is representing x is 0, y is 0, and z is 1. So this means it is representing 0, 0, 1, which is m of 1, right? Now the next adjacent box is representing x is equal to 0, y is 1, and z is 1. Now this is representing 0, 1, 1. Now 0, 1, 1 is basically representing m of 3, right? Because it is 0, 1, 1. Then the next adjacent box, which is over here, is x is 0, y is 1, and z is 0, which is representing m of 2 over here, right? Now we come to the next row where x is equal to 1. So x is 1, y is 0, z is 0. So 1, 0, 0, which is representing m of 4, right? Then we have x is 0, x is 1, y is 0, and z is 1. So it is 1, 0, 1, which is representing m of 5 over here. Then we have x is 1, y is 1, and z is 1, which is representing m of 7 over here. And then we have 1, 1, 0, which is representing m of 6 over here, right? So in this way we are actually able to label the boxes with their respective min terms, right? Are you with me? And similarly, the boxes can also have their respective literals or variables accordingly, which we can say x, y, z. Again, x is 0, y is 1 over here. Then 0, 0. Then 0, 1. Again, there is only a change of one of the variable. Then 1, 1. Again, a change of one variable. And then 1, 0. Again, a change of one variable only. So the first box, which was being represented m of 0, it is over here x complement, y complement, and z complement. Then we have m of 1. M of 1 is represented as x complement, y complement, and z, right? Then we have 0, 1, 1. 0, 1, 1 is being represented as x complement, y, and z, right? And then we have 0, 1, 0, which is x complement, y, and z complement, right? Then m of 4 is represented as x, y, and z complement. Then m of 5 is x, y complement, and z. Then m of 7 is represented as x, y, and z. And then we have m of 6, which is represented as x, y, and z complement, right? So in this way we are able to see how we are going to label each and every box with their respective min terms and the respective equivalent of the min term uh, product form, right? Okay, now let's suppose we have a function which is being given to us. Any question? Question?
No, sir.
Okay, that's fine. Okay, so if we have, let's suppose a function which is being given to us, function is equal to x complement, y complement, we have, let's suppose a function is equal to x complement, y and z plus x complement, y and z complement plus x, y complement and z complement, and plus x, y complement and z, right? Now if you see which specific boxes will be labeled in the K-map with these functions. So let's see. Because we have 3 variables, so this means we are going to have 8 boxes that is going to be made for this function. And x is equal to 0 and x is equal to 1, y is equal to 0, 0, then y is 0, 1, then 1, 1, and then 1, 0, right? So the first one is x complement, y and z. X complement, y and z. So this is representing which minterm? Anybody?
M of 3.
This is representing m of 3, so we will label m of 3 over here, right? Then we have x complement, y and z.
M of 2.
X complement, y and z complement, which is m of 2, right? Then we have x, y complement and z complement. This is representing
M of 4.
this is representing m of 4, right? X, y complement and z complement, right? If
M
you,
of 5.
this is, and then the next one is x, y complement and z, which is representing m of 5 over here,
5.
right? So what we see, we have labeled the respective min terms in the K-map, right? And once we have done this, then what we can do, we can actually try to minimize the number of terms. And how we can do that? By making groups over here. If you see, we can make a group of 2 with the adjacent boxes. We can make a group like this. And again, there is another group can be made with a group of 2, which is the 2 adjacent boxes, right? So the groups can be either made horizontally or they can be made vertically. Now if you see how we can make this group. Now in this group, if you see what is not changing in the horizontal direction. In the horizontal
Y.
direction, what is not changing is x complement is not changing,
Y.
right? And in in the horizontal direction, what is not changing? If you see, the y is 1 over here, again the y is 1 over here in the 2 adjacent boxes, right? So this means y is not changing, and in the vertical direction we have the x complement. So this means this group will be made as x complement y. Are you with me?
Yes, sir.
Any question up with this?
No, sir.
Okay. Similarly, the second group over here, which is this one, in this, if you see what is not changing in the horizontal direction,
No, sir.
what is not changing in the horizontal direction for the second group,
X.
Z.
what is not changing?
Y.
If you see, y is 0 in this box, y is
And
in this box, right? So in the 2 adjacent boxes, y complement is not changing, and in the horizontal direction we have x. So this means we can make a group x, y complement.
Y complement.
Are you with me?
Yes, sir.
Right? So we can make a groups like this, and if you see, with this we are able to